This video covers required practical 4, which is determining the temperature change when an acid is added to an alkali. We'll cover a method for this practical, a summary of the method which you could use to answer an exam question on this topic, and some example data and how we would analyse that data. You would set up this practical by standing a polystyrene cup inside a beaker. The first step is to measure 30 centimetres cubed of hydrochloric acid using a measuring cylinder and put it into the polystyrene cup. You would then use a thermometer to measure the temperature of the hydrochloric acid, recording the result. You would then measure 5 centimetres cubed of sodium hydroxide using a measuring cylinder. Next, you would pour the sodium hydroxide into the polystyrene cup, fit the lid, and gently stir the solution with a thermometer through the hole. When the reading on the thermometer stops changing, record the highest temperature reached. Repeat all of the steps you've done so far, adding a further 5 centimetres cubed of alkali to the cup each time. Record your temperature reading in the results table and repeat until a maximum of 40 centimetres cubed of alkali has been added. Repeat the experiment for a second trial so you've got 2 sets of results. We'll now look at a summary of the method you could use to answer an exam question on this topic. The first step is to use a measuring cylinder to measure 30 centimetres cubed of dilute hydrochloric acid into a polystyrene cup. You would then stand the cup inside a beaker and use a thermometer to measure the temperature of the acid. This will be your starting temperature. You would then measure 5 centimetres cubed of sodium hydroxide solution using a measuring cylinder and pour the sodium hydroxide into the cup. Next, you'd put the lid on and stir the solution using the thermometer. You would then take the reading of the maximum temperature reached. You'd repeat this experiment twice so you could have a mean value. You'd then repeat each of these steps and add a further 5 centimetres cubed of sodium hydroxide each time until a total of 40 centimetres cubed has been added. We'll now look at some example data for this practical. This is the maximum temperature reached for each volume of sodium hydroxide added in the first trial. And this is the maximum temperature reached for the second trial. We would then need to work out an average for each volume added by adding both values together and dividing by 2, as we have done 2 trials. So we now have an average temperature for each volume of sodium hydroxide added. The next questions ask you to do some graph work. So you'd need to use graph paper to plot a graph with the mean maximum temperature in degrees C on the y-axis and total volume of sodium hydroxide on the x. You'd then need to draw 2 straight lines of best fit, one through the points which are increasing and one through the points which are decreasing. You'd need to ensure the 2 lines are extended so they cross each other. Finally, you would then use your graphs to estimate how much sodium hydroxide solution was needed to neutralise 25 centimetres cubed of dilute hydrochloric acid. This is a graph with the mean temperatures we worked out a moment ago plotted. We can see we've got a section which increases and a section which decreases. We'd then need to draw 2 straight lines of best fit through these sets of points. We can now see 2 straight lines of best fit have been added, and we've extended the lines of best fit beyond where the points are plotted, so there is a crossover point between them. This crossover point is the volume of sodium hydroxide which would need to be added when neutralisation took place.